In this video, we're talking about parallel lines cut by a transversal. All right, so parallel lines, those usually have little arrows or triangles on them to indicate that they are parallel. A transversal is just any other line that cuts through both, or maybe there's even 3 or 4 of those different lines. And what that does is it creates a few different kind of intersections, and the angles that this makes, like here, this is one intersection at the top here and one intersection at the bottom. The angles that those make have some special properties that we're going to talk about in this video. We're going to talk about kind of the 4 main types of special properties that they have. We're going to show you how to kind of travel from one to another, some of these different angles. And last, we're going to finish up with some problems where we insert some algebra into those different angles, and we're going to solve for those. All right, let's try it. All right, so we're going to start here by talking, if we do have those parallel lines cut by a transversal, there are 4 different types of special angles that this makes. We have corresponding angles, alternate exterior, alternate interior, and consecutive interior angles. And the name kind of tells exactly what those mean. All right, so for example, corresponding, this usually means that something relates to another thing. And if I look at these kind of 2 different intersections right here, and let's take like A, for example, the first one. This is in the top left kind of corner of that intersection. So in the other intersection, which one's in the top left? E. E is in the top left. So you could say that A and E are corresponding angles. So I'd say angle A is corresponding to angle E, and moreover, those angles, if these lines are parallel, they are congruent. So I'm going to say angle A is congruent to angle E. All right, now there's obviously others besides that. If I look at the top right, we have B, and the top right over here would be F. So B and F. In fact, I'm going to write out all the other corresponding angles for you. All right, so there you go. We have kind of those 4 pairs. The top lefts, bottom lefts, top rights, and the bottom rights. Those are all going to be congruent if our lines that those are cutting are parallel. Okay, the next type we have are alternate exterior angles. And this, again, like the name sounds, alternates kind of mean on either side of that transversal. So one has to be on the right side, one has to be on the left side. And then exterior, if these are my 2 lines, they have to be on the outside of those. So they're going to be, if again, I kind of think inside versus outside. Alternates, so if I take A again, it's on the outside of those 2 lines, and on the opposite side down here would be H. So they're outside those and on opposite sides of the line. So I'm going to say A, again, these are congruent if they're alternate exterior angles. So angle A is congruent to angle H. And then there's only one other one. Can you see it? It's going to be B and G. They're on opposite sides of our transversal, left and right, and they're on outside of those 2 parallel lines. So I'm going to say angle B is congruent to angle G. All right, alternate interior angles, same thing. This time they're just on the middle. So I can say C and F are congruent. Angle C and F on opposite sides and on the middle there. And the other one's going to be E and D. Angle E is congruent to angle D. All right, now those first 3 that we talked about, corresponding alternate exterior and alternate interior, these are all congruent angles. However, the last one, consecutive interior, these are not. And if you just kind of look at the picture, you might be able to see this, right? Like I know, or you can kind of tell this is an obtuse angle. It's going to be more than 90 degrees. If I were to hold up like a corner of a paper, which is 90 degrees, and put it there, that would be more than that 90. And same thing down here. This one isn't more, but it's less. So those can't be congruent to each other, but they are going to actually be what's called supplementary, or they add up to be 180 degrees. So the way I would write this is I would say C and E. They're consecutive on the same side. They're interior. And I'm going to say that angle C plus angle E equals 180 degrees. Those are supplementary angles. The other pair on the other side, D and F, same thing here. Angle D plus angle F equals 180 degrees. All right, and you can use that fact to help you find others in here that are also supplementary, which we'll get to here in just a little bit. All right, so if you remember what I said earlier, sometimes there can be just 2 of those lines, but sometimes there's more. In this case, we have 2 lines going this way that are parallel because they have 2 triangles, and 2 lines that are going up and down that are also parallel. So this creates how many different intersections? We have 1, 2, 3, and 4. And because of that, we have some special angle relationships we're going to try to mark out based off of those 4 different types from earlier. And I'm also going to throw in, so we have alternate interior, alternate exterior, corresponding consecutive interior, and then I'm also going to say none is a possibility as well, as there's going to be a few in here that don't have any of those special relationships. All right, let's try them here. What about A and H? So let's find both here. We have A and H. Well, compared to the line that they are on, they are outside of those other two lines. And so that would make them exterior. And because they're on opposite sides, they're alternate exterior. And I'm going to abbreviate these today. So let's say AEA, alternate exterior angles. The next one, F and G. F and G, those are on the same side of those two lines. So again, kind of find the line that they both share, and then the other two will be your parallel lines. And these ones, are if they're on the same side and on the inside of those are going to be consecutive interior, CIA, consecutive interior angles. All right, next we have J and O. J and O, again, those are sharing this line, and so they're in between the two other parallel lines here, and they're on opposite sides. Those are going to be alternates, because the opposite sides, and then interior, because they're between. So alternate interior angles, or AIA. F and K. Where's F? There's F, and then K is down here. Do those two share a line? No, they don't. All right. So because of that, they don't have any special relationship. You might be able to figure out what if they're equal to each other, if they're supplementary. But as far as the special relationship goes, this one is none. All right. M and B. Let's see here. M and B. These ones do share a line. Okay. And compared to that line, the other two are going to be our parallel lines. They are on opposite, or on the outside and on opposite sides here. So that's going to be alternate for the opposite sides. And then since they're outside, it's going to be exterior. So alternate exterior angles, AEA. C and K, our next ones. C and then K, these ones share a line. And they're both in the top left spot. So these are corresponding angles. So top left, top left. So corresponding angle, I'm just going to say CA for this one. Corresponding angles, L and G. Where's L? L and G. These ones also share a line, and the two parallel lines are here and here. And so because of that, it looks like they are on opposite sides and in between. So that's AIA, alternate interior angles. H and F. H and F, again, these ones share a line. They're on the same side, and they're both in the bottom right position. So that's corresponding angles again. Say CA. M and K, these are both on the bottom line. K is here, M is there. Let's see, this one, I don't think that would have any, right? Even though they're on the same line, they're alternates, but they're not both interior. The K is inside, but the M is outside. So I think this is also going to be none. Does not work for that one. Last one down here, it says P and N. P and N, these are both along that line, and in their respective corner, they're in the bottom right. So that's going to be corresponding angles. All right. Now there's two other types of relationships that you've probably heard before this lesson, and that's going to be if I had, let's see if you can figure it out, angle, let's say K and angle P. All right, so K and P right there. Do you know what types of angles those are? Those are actually called vertical angles, right? Vertical angles. And vertical angles are congruent to each other. So if they make that kind of X-type shape, I just kind of highlight the ones that they're on there, it makes an X, and they're on opposite sides of that X. And since they're congruent, I'm going to say angle K is congruent to angle P. Okay, another type that's not congruent, but it's supplementary, is if I take like M and N. What about angle M and angle N? These are both along a line, right? And they're on either side there. And because a line is a straight angle, this is going to be 180 degrees. And that means that these together make up what's called a linear pair. So they add up to be 180. And they make a linear pair. All right, so we can use vertical angles, linear pair, along with our other four different types: consecutive interior, alternate exterior, and corresponding angles to help us in our next section. All right, so now we have a bunch of different angles here, and I tried to draw the best I could. It might not be perfect, but the ones that are horizontal, you can see, are all parallel. The ones that are more vertical are also all parallel, okay? So we're gonna try to go from angle 1 all the way down and around up to angle 14, and we're gonna show kind of the different types of angles we use to travel from those kind of lower angles all the way up to the higher angle of 14. All right, so let's try. If I want to go from angle 1 to angle 2, what special angle relationship do they have? Well, these are corresponding. They're both in the top right of their respective intersection. So I'll say corresponding angles there. What about 2 to 3? Those are alternate interior angles. AIA, both in the middle of these two. And then they're on opposite sides. All right, to go from 3 to 4. 3 to 4, these ones are also corresponding like our 1 and 2 was. These are both in the bottom left of their intersection there. So again, corresponding angles. What about from 4 to 5? These ones, if you look at the line that they share, they're inside the two parallel lines and they're on the same side. So these are consecutive interior angles, or CIA, consecutive interior angles. 5 to 6. These ones are both in the bottom right of their intersection. Bottom right, bottom right. So these are corresponding. CA. 6 to 7. This one's a long stretch, but it's still okay. It's along the same line. These are both on the inside of their two lines, but on opposites. So these are alternate interior angles. AIA. 7 to 8. These are going to be corresponding again, both top left, top left. So corresponding angles are pretty prevalent. There's a lot of those. 8 to 9. 8 to 9. If you look at the line that they share, the two parallel lines are on the outsides of those and on opposite sides. So alternate exterior angles. AEA. 9 to 10. These are again corresponding both in the bottom right of their intersection. So CA. And then 10 to 11. This is one of those ones I mentioned kind of in the bottom of my last portion of this video, and that was that these are vertical angles. They make that X-type shape, and they're on opposite sides of that X. So these are going to be vertical angles. I'll say VA for that one. 11 to 12. 11 to 12, again, on the same side. So they share this line. Here is our parallel lines. They're on the same side, and they're both inside. So those are going to be consecutive interior angles. CIA. Almost done here, 12 to 13. This is another one of those special ones. These ones are right next to each other, and they form a linear pair. All right, I'll say LP for that one, linear pair. And then lastly, 13 to 14. Well, they share this line, and they're on opposites. And let's see here. Oh, you know what? This one, that's right, I did throw in a none on that one. This one does not have a special relationship. If we wanted to, since one's on the outside, one's on the inside, if I did want to make this have a special relationship, I could put the 14 over here. In fact, let's just do that. So don't want to undo all of our work here. Now these are going to be corresponding angles because they're both in the top left. All right, so CA, we'll say corresponding angles like that. All right, now let's solve some of these problems with a little bit of algebra thrown in. All right, so I have a couple of problems here that involve some algebra with our parallel lines and our transversal, all right? And with this, what we're trying to do is kind of one of two things. We're trying to figure out, do our angles, are they congruent? Or are they supplementary? In other words, are we going to equal them to each other because they're the same? Or are those together added up to be 180? Are they supplementary? And in this case, if you think about what kind of angle relationship this and this are with our parallel lines, well, those are on the outside and they're on opposite sides of our transversal. So those are alternate exterior angles. If you go back to the very beginning of this video, you remember that those are congruent. So I can set 3x plus 30, this one, equal to the other one. So I'm going to say equals 5x minus 20. And now we can solve for x here. And so I would subtract 3x on both sides and get 30 equals 2x minus 20. Add 20. We get 50 equals 2x. So if I divide both sides by 2, I think I'm going to have 25 equals x. Now, sometimes your problem might say to solve for x, or it might say, solve for the given angle. Let's say I want to solve for this angle up here. What would I do with this 25? Well, I would plug it back in and we could figure it out. So here I would say 5 times, not x anymore, but 25 minus 20. And what is 5 times 25? That's like 5 quarters. So $1.25, right? Or 125, you think like this, and then minus 20, that's going to be 105. And because these are congruent, without even doing the math here, I also know this is 105 degrees as well. All right, in our second one, this time, if I think about what type of relationship does this angle and this angle have, it doesn't really have one. So you have to kind of use and manipulate those a little bit. knowing that these two lines are parallel. All right, what I probably would think is that across from these, this angle right here and that angle right there, I might give this one 2 little loops because these are all vertical angles, this one and this one. And if I were to kind of slide these down to the middle, now those would be consecutive interior angles. So even though they start on the outside, you can kind of manipulate them and move them to where they could be a special angle measure, or a relationship, I should say, and then do that math from there. So I know that consecutive interior angles are supplementary. So on this time, I'm going to set these, or add these up and set them equal to 180. I'm going to say 7x plus 90 plus the other one, 3x minus 10 equals 180 degrees. And then I can solve for x here. So I'm going to put together my like terms. 7x and 3x is 10x. 90 minus 10 is 80, a positive 80, equals 180. If I subtract 80 on both sides, now I have 10x equals 100. And if I divide both sides by 10, x equals 10. All right, again, it might want you to solve for x and say you get 10 there, or you might want to plug that back in. And let's say I want to find this one. This time if I plug them back in, I could actually find both, right? And they're going to be different. I'm not going to know they're the same. But if I plug into this one, what's 7 times 10? That's 70. Plus 90 is going to be 160 degrees, which means this one better be 40 because those have to add up to be 180, is it? If I plug in 10 here, 10 times... or I'm sorry, it should be 20. My fault there. 10 times, looking at that math, that doesn't work. 10 times 3 is 30 minus 10. 30 minus 10 is 20. And yeah, I'm not 40, but 20. 20 plus 160, that is our 180 degrees. And just like we were able to solve for. All right. So hopefully this video on parallel lines cut by a transversal helped you out. All right. And if it did, until next time, keep doing your math homework fast and accurately.